In this video, we are going to create a simple intro video animation using Blender EV Engine. You will learn about how to manage render settings, manage rigid body physics to simulate Blender animations, how to use Blender force fields, and create random color-based material. Finally, you can render smart intro animation video using EV Engine, and the last part of the video will guide you to create more stuffs using this intro animation. First, create a new Blender project, and delete all objects in your viewport. In this session, we use solid text for the intro video. Therefore, add a text and turn your viewport into front view. Now zoom into the text. After that, go to the object data properties of the text and set the alignment of paragraph horizontal to center. Now, go to the viewport and hit Tab to edit the text, and type anything you like to display for the intro animation. Now hit Tab again to complete the editing. This text in the default font for itself, we need to change this font type to get different styled text. Therefore, go to the font drop-down in the object data properties of the text. You can see there are too many options to get different type of font. But the problem is all the panels are empty, therefore we have to set these fonts manually. First, we need to choose a font by font file. Just click the open font at the regular and see what will it shows. You can see there is a list of fonts, but you can't see the styles of the fonts. First you must make sure you are in this location. We need to see the font styles and choose a font for this theme. Therefore, open this location in your File Explorer. Now you can see it shows fonts with styles of it. Scroll down and see what type of the font you need. Now select a font and right-click it, and go to the properties of the font file. Now copy the name of the font, and minimize or close the File Explorer, and move into the Blender. Now paste the name what we copied for the search bar of the Blender. After that, select your font, and click the Open Font button. After opening the font, you can see font of text, what we created is changed. Now, move your viewport slightly, and you can see the text isn't solid. We need solid text for this intro video. Therefore, go to Geometry drop-down in the Object Data properties of the text, and set the value of Extrude to 0.2. Now convert the text into mesh. To do that, select the text, and select the Object menu at the header, and open the Convert to menu, and select the mesh from Curve, Meta, Surf, Text option from it. Now, text what we created is converted into mesh. Hit the tab to turn into edit mode, and you can see it is converted as a mesh. Now hit the A key, and select all vertices, and hit the Ctrl and T to cross-cut. Doing these cross-cuts will help to improve the rigid body simulation of this object. Now we done the editing part of the text. After all, add a UV sphere, and move it, and scale it 0.2 times. After adding, smooth its shading. Now move the created UV sphere to new collection. After that, move it slightly to the corner of the text. Now duplicate the created sphere using following keys, and move it in the x-axis 0.4 meters. We need 10 spheres in the x-axis, therefore, use the following keys to repeat the activity. Now select the duplicated 10 spheres, and do the same thing in the y-axis. But this time, do it 5 times for now. After that, select the duplicated 50 spheres. We don't need this text part for now, therefore, hide the collection one for a while. After that, turn the viewport into the front view, and duplicate the selected spheres and z-axis. Use the same 0.4 meters distance to move. Now, repeat that activity 10 times. After that, you can see you have 500 linked UV spheres. We can also do the duplication process using Shift and D keys. This method will create the separated object data and materials for the duplicated objects. But in this session, we used Alt and D keys to do duplication. This method will create the linked object data and materials for the duplicated objects. And this method will save your system memory and decrease the render time also. We can duplicate the created object again. It will give more spheres for our scene. Now select the created spheres and duplicate it, and move it 2 meters in the y-axis. After that, turn your viewport into front view, and change the viewport shading into wireframe. After that, do the same selection procedure following. Now, we need to scale out these selected objects separately. Therefore, move to the header, and change the transform pivot point to individual origins. Now, scale the spheres 0.5 times. After that, turn the viewport shading into solid. Now, we have created our sphere particles for the intro video. After creating spheres, we need to apply the rigid body physics for these spheres. To do that, first select all spheres in your viewport. After that, go to Object menu at the header, and select the Rigid Body menu, and click the Add Active option. It enables the rigid body physics for the objects what we selected. Now, go to the physics properties, and change mass of it to 0.05 kilograms. And change the collision shape to sphere. But, this physics data will change the effects for the activated object only. Therefore, we need to apply these changes for the other spheres. So, go to the Object menu in the header, and select the Rigid Body menu, and click the Copy from Active option. This option will copy the physics data of the activated object to the selected other objects. You can see all objects had the physics data we applied. Now we completed the physics data setting for the spheres what we created. Now go to the collection of the text what we created early, and make it visible. We also need to apply the rigid body physics for this text. But this text part will not move. To do this, select the text, and go to the physics properties, and click the rigid body physics, and change the rigid body type to passive. It will make this object as unmoving passive object. After doing that, now change the collision shape to mesh, and set the friction value to 0. We don't need friction for this text. Now we completed the applying physics data for the objects what we created. Now, we need to move the spheres what we created like an animation. To do this, first turn your viewport into the front view, and check whether your 3D cursor located at the center. Now, add the force of the force field into the viewport. After adding the force, move it slightly to the top of the text. Now go to the physics properties, and set the strength value of it to -50. We need the occurred movements for the physics simulation of the objects. For that, go to the scene properties, and open the rigid body world drop-down, and set the steps per second value to 120. Increasing the steps per second value will make the results more accurate for the rigid body physics. Now go to your timeline, and click the play animation button. Now Blender will simulate the physics for these objects. When these spheres are covering the full of the text, then click the stop animation button. For this scene, we need to save these positions for all the spheres. To do that, select a sphere in the collection to and right-click that collection. Now click the Select Objects option. After selecting, go to Object menu at the header, and open the Rigid Body menu, and click the Apply Transformation option. After applying, click the Jump to the Endpoint button in the timeline. Now, you can see the objects are at the same position on the start keyframe. After that, select the force, and change the strength value of it to 0. Now turn your viewport into top view, and add a camera. And hit the following keys to place it in the top view. Now open the Properties region panel, and place the camera with following X, Y, Z axis values. After that, select the force what we created, and move it to the first collection. Now go to the Physics properties, and change the type of the force field to wind, and change the strength value of it to 15 for now. After changing values, now click the Play Animation button to simulate the physics. And turn your viewport out of the camera view, and see how it works. Now turn into the camera view, and see how it works. You can see that all the spheres are moving together, and they are hitting the camera. It is not giving any special effect for our scene. Therefore, add a turbulence force field into your viewport, and click the Jump to the Endpoint button in the timeline. After that, set the strength value of the turbulence to 10. Now, click the Play Animation button in your timeline. And you can see now it simulates the wind with turbulence. In this scene, turbulence will give some noise for the wind. You can change the strength and size values of this turbulence, and then it will give more different effects for your intro animation. In this intro animation, set the turbulence size value to 2. And move your turbulence force to the first collection. Now select the wind force what we added first, and set the strength value of it to 13. Now you can see our animation is doing well. After all, go to the Scene Properties, and click the Bacall Dynamics button under the Cache drop-down. For this intro animation, we done the animation part of this video. We need to see more animated spheres in the animation. Therefore, select your camera, and open the Properties region panel. And slightly move your cursor of timeline, and change your camera position as you like. For this intro animation, place the camera 20 meters in the Z-axis. This amount of distance will cover the big area of the animated spheres. And we need to bring the text at the center of the camera. Therefore, move the camera 0.2 meters in the Y-axis. Now click the Play Animation. You can see, our animation is doing well. After all, save your project. Now we need to create the materials for these objects. First change your viewport into rendered. And you can see, it is totally ash colored. Go to the World Properties, and click the color value under the surface drop-down, and set the V value of it to 1. Now you can see, your viewport is totally white colored for your scene. It gives white colored lighting effect for the Blender world. Now select one of the UV sphere, and go to the Material Properties. And create a new material for it. After that, split your viewport into 2 parts, and change the editor type to Shader Editor. Now you can see the principled shader of your material, in your shader editor. The material what we created is automatically linked with all spheres. In this material, changing the color of the principled shader will give same color for the all spheres. We need randomized colored spheres for this animation. Therefore, add a object info node into the material. After that, add a hue, saturation node into the material. Now, connect the nodes following like this. After connecting nodes, you can change the color value in hue, saturation node, and see the color changing of the spheres. Set red color for this material. It can be any color as you wish. What's happening in this node flow? Random value of the object info node will give randomized number for every object with this material is connected. If we connect this random value to the hue value will be random. And this value will multiply with the color value of the hue, saturation node. Finally, this node flow gives the randomized color for all the spheres. Now, change the principled shader's values, and see that which type of material will match for this animation. For see more effective details of the materials, enable ambient occlusion render feature in the render properties. Changing distance value of the ambient occlusion will give more reality for this animation. For this intro animation, set distance value to 0.8 meters. Finally, set materials metallic value to 1, and set roughness value to 0. Now go to the timeline, and click the play animation button, and move the spheres to clear the area of text. And select the text, and create a new material for it. Now, click its base color of principled shader, and change the V value of it to 0.25. And set the metallic value of it to 1, and roughness value to 0. Now go to the start frame in your timeline, and click the Show Over Layers. And close the shader editor. Now you can see the created materials are blending light perfectly. For this animation we don't use the screen space reflection, because it gives the noisy reflection for this scene. So, we didn't use that render feature for this scene. Now, we just have to render this intro animation. For do that, we need to set some settings to get output file as a video. Therefore, go to the output properties. Now change the file format to AVI, JPEG. And, set quality to 100%. Now change your viewport shading into solid view. After setting it all, now render the animation. You can minimize this window to see the rendering process in the timeline. After rendering, you can get your video file in System Local Disks temp folder. Now we done with the intro video with default render setting. Default render settings of Blender have 24 frame rates by itself. And, this is the animation we created and rendered with 24 frame rates. Increasing frame rate will give best Blender physics simulation. Therefore, simply set your frame rate to 30, and click the play animation button. You can see, there are no any physical simulations happened in the animation. It just speeds up the animation, and fills up the frame rate. Just set your frame rate to 60, and click the play animation button. Now you can see it clearly, it speeds up the animation. We have to fix this. First turn the frame rate to 30, and go to the scene properties. Now click the delete all bakes button under the cache drop down. And, try to simulate the animation by clicking the play animation button. You can see, there are no changes would happen. Because, we didn't change any rigid body physical data at this moment. Without changing any rigid body values, or objects, Blender will not do the physical simulation in this scene. Therefore, just change the steps per second value, or just click it, and hit enter. Now Blender will understand, there are some physical changes are happened. After that, click the play animation button. Now Blender will simulate the physics for your animation. And you can see, the spheres will fall away with physics in this scene. Increasing frame rate will always affect for the Blender physics simulations. You can see, this simulation is totally different than the first scene what we created with 24 frame rates. We need to get the animation like how we done first. To do that, select your wind force, and change the strength value of it to 17. Now click the play animation button to re-simulate. You can see, that it is doing well for the scene, but if we have more than one force fields for our scene, we have to change each of one. Therefore, we can use this shortcut method to simulate that type of scenes. First, change the wind strength value to 13 what we used value first. After that, go to the scene properties, and click the field weights drop down. And, set gravity to 0.8. Now click the play animation button, and see how it works. It works fine for this scene. You can see, we need more frames to end this animation. Therefore, click and change final frame of the playback to 360. Now, click the play animation button, and you can see, it will don't simulate for these frames what we extended. Go to the scene properties. And, change end value under the cache drop down, to 360. This is the frame range for the Blender Rigid Body World simulation. Now click the play animation button, and you can see that it is simulating. Simply click the Bake All Dynamics button under the cache drop down, to save the baked animation. Now you can save your project, and render the animation with good frame rate. Now you have to know this, we need to set our frame rate first, for any of the animation project what we create in the Blender, in the future. After rendering, this is the rendered video. You can see, that it's smoothness of the animation. Now you can do anything, with this workflow. Use different font types to make your text better. Use different forces to animate your objects. Use different camera positions to capture the animation. Use more amount of the objects to make it better. Use different type of objects to make your scene different. You can use fixed, or moving camera position for your animation. Do anything you like, and render your logo, text, your 3D models, and more things with this animation. Make it your own. If you like this video, hit like button. If you have learned something new, hit subscribe. If you hit the bell icon, you will get notifications as soon as we upload a new video. Learn with IBM. Thank you for watching.